Guys, I left you with this description. We talked about the definition of diastereomer and how that's different than the definition of enantiomer and how that's different than the definition of a stereoisomer. So we said that all four, what you're seeing on the screen right now, are stereoisomers because it's the same structure, folks. It's just pointed in different directions. That's really all that we're talking about because those carbons have four different groups and it makes them very special. Those are chiral carbons. So all four of these are stereoisomers of each other. And then we said in particular, if there are mirror images, then that's the definition of an enantiomer. And then if they're not mirror images, but they are still different in the way that they point, we call those diastereomers. All right, so let's do an example, shall we? Multiple chiral centers. I'm going to have to name them. I'm going to have to associate an R or an S with each one. How can we do it? So let's look at an example. Let's take this one. All right, so I see the structure on the screen. It's drawn in a way that gives me perspective formula. So they want me to get a clue about what R and S is on each chiral carbon. I see dashed and solid wedges here on this carbon, which makes this a very good sign that it is chiral because that's where all the action is. Okay, I see how this is starting to work. This carbon is not chiral because there's 3 hydrogens on it. This carbon down here at the bottom, that one's not chiral because there's 3 hydrogens on it. So I have 2 chiral carbons here. I have this one and I have this one. So this question wants me to look at this structure. I have 2 chiral carbons. It wants me to name it. But they at least gave me the base name, 3-bromo-2-butanol. How did they do that? All right, but is 4 carbon. 1, 2, 3, and 4. There's the longest carbon chain, zigzaggy. 2 means that's where the alcohol is at, OL. So carbon 1, carbon 2. There's the chiral center. That's where my OH is at, 2-butanol. My carbon 3, I have a bromo group. That's where the 3-bromo comes in. So they want me on carbon number 2 to give you an R or an S. And then they want me to give a R or S on carbon 3 because that's where the chiral centers are located. How do we do this? Folks, there's no difference. There's no difference in what I've told you already. They just want to make it a little bit more complicated for you. That's all that they want to do. So first off, let's look at the carbon to the left. I have a CH3 group as one attachment. I have a hydrogen as my second attachment. I have my OH group as my third attachment. And then over here to the right-hand side, I get this carbon with another carbon and a bromine on it, and there's my other attachment. What did we do? We put lower priority in the back. That's where we started, wasn't it? Yes, that's where we started. Is my lowest priority in the back here? Ding, ding, it is. All right, well, at least they set that up for me the right way. So we use our rules that we've always used up to this point. What does that mean? Which one of the 3 are your higher priority, is the highest priority? I hope you're going to tell me OH, because that oxygen beats out that carbon and beats out that carbon. Okay, well, what would come next? We have a carbon and a carbon that's tied. Well, this one runs out, and this one has a whole bunch of crap with it. So that one with the whole bunch of crap is the one that's number 2. So this is going to be spot number 2. And then this methyl group up here, this is going to be spot number 3. So if I look at the rotation, OH group, then that points there, that points there. Folks, that's counterclockwise, isn't it? Okay, well, none of the rules that I have just did has changed. Nothing that I just told you was anything new. It was all a repeat. It was all a rehash of the same stuff or crap that we've been talking about all this time. If this is a counterclockwise rotation, what is that, R or S? Well, I hope you're going to tell me S. Counterclockwise is S. Okay, well, you've assigned the stereochemistry to that first carbon. Nothing new, nothing exciting, nothing there that I have to stress that I haven't already. So I'm going to erase all of that garbage that we just did around that chiral carbon, and now I'm going to look at the other one. We're going to do the same thing. We're going to do the same thing that we just did. But there's a problem. I see my Br group, group 1. Hydrogen, group 2. Methyl group, group 3. And then carbon with all the crap. That's group 4. 4 different groups, chiral carbon. Which one's my lowest priority? Hydrogen. Okay, well, we put it in the back. We put it on a dashed wedge. Not this time. They locked you. They prevented you from doing that because they put it on a solid wedge, not a dashed wedge. Oh no, we've not really did an example like this, have we? Is this going to make it more difficult? No. Do you remember what we did with Fisher projections? Vertical bonds and horizontal bonds. And I said, hey, if the hydrogen is on these particular types of bonds, well, you just got to remember that in the end. You kind of rank them like you always did. You circle them just like you always did. You assign it R or S just like you always have. And then at the very end, you just pick the other one. That's what we do here. The hydrogen is not on a backward bond. So whatever we determine here, it's going to be the opposite of, because it's on the opposite bond of what we like to see. It's forward, it's not backward. So, use the rules like you've always done. Bromo, carbon, carbon. Bromo gets group 1. There we go. Highest atomic number, that's all it takes. Now, carbon, carbon's a tie. You go on to the next one. Carbon with a bunch of other crap, and then this one runs out. So carbon with a bunch of crap is going to come number 2, and then this methyl group down here is going to be carbon number 3. If I look at this, this goes from 1 to 2, 2 to 3. Folks, this is counterclockwise, right? This is a counterclockwise rotation about the chiral center. That counterclockwise rotation normally would be an S, just like it was over to the left-hand side. But the problem here is that hydrogen is on a forward-facing bond, not a backward one. And just like with Fisher projections, it's on the opposite type of bond that we like to see. So therefore, we pick the opposite of what we end up with. And this side is a R, not an S, because I'm looking at the molecule from the back end, not from the front end. That's how we determine that. That's the easiest way to fix it. Use the rules that you've always used for everything. That's what we've done. Every example that's came forward. And here, it was just like Fisher projection, where hydrogen was not on the backward-facing bond. And because of that, it's on the opposite bond than what we like to see. Well, we pick the opposite of the correct answer. So what this means is that this molecule's name, on my second carbon, I have the S rotation, stereochemistry-wise. On the third carbon, I have the R rotation, stereochemistry-wise. Therefore, I put that in parentheses, and then I write 3 bromo 2 butanol as a name for that structure. That's how we answer problems like that. Okay? So, let's do some more examples. We're going to start off little, And then we'll do another example that's a little bit more complicated. And we see if we can pull this off. So this example problem says, draw perspective formulas. Okay, perspective means wedge. That's what that means. That's what they want me to draw. Wedges for the following compounds. R2-butanol and 2S3R, 3-chloro-2-pentanol. All right, so let's start with the first one first. It seems like it's going to be a little easier. Only one thing that I have to worry about. R2-butanol. I have to draw it. Bute's how many carbon? I hope you can tell me that at this point. I hope that you can tell me that bute, out of everything that we've done, represents 4 carbon. 1, 2, 3, 4. Okay, well, all is an alcohol group. That's OH. And this is going to be on the second carbon. So on the second carbon, I have an OH group. So here's the structure. I have to draw this in a perspective form, though. Not what we just did. This is what we've been doing, folks, right? So I need wedges. I need solid wedges, dashed wedges. I need to give you an example of 3D. I need to tell you which one's pointed backward, which one's pointed forward. So the first group is this methyl group, CH3. The next group is the ethyl group over here to the right, CH2CH3. My third group is the OH. And my fourth group, it's not written, but it's understood to be a hydrogen. There's my 4 different groups. All right, so here's the chiral carbon. I only have one of them. This carbon has 3 hydrogen. That one has 2. This one has 3. That carbon is the only carbon that has 4 different groups. So that's my center. And this is how I start off. But there's a difference here. The difference is that this particular problem wants me to give an R, not both. Therefore, I can't be willy-nilly like I was on the other example problems. I have to be very specific here. So we set this up just like before. What is my low priority group? Well, you're going to look at those groups, and I hope you tell me hydrogen. That's the lowest group number out of all 4. So, yes, you're going to tell me that. I know you are. And this is going to go on the back side. So, by default, they're giving me freedom at least to do this, but they want the R rotation. Okay, well, what's your high priority group? I'm going to start there first, and you know where I like to put the high priority groups. I like to put those up at the top, at the 12 o'clock position. Well, I have a carbon, I have an O. That oxygen is going to be my higher group number. So OH is going to get spot 1. That's rank 1 out of all 3 that's left over. Now here's where I have to be careful. I need R, which means my rotation better go this way. It better go clockwise. So I have 2 groups here that I need to worry with at this point. Which one is ranked next? Well, that's my ethyl group. Carbon-carbon tied, carbon on the left, methyl group runs out, and then my ethyl group has another one that I can pick from. So ethyl has a higher rank than methyl does. So that means I better put my next rank in line at that position right there. And then that will mean my methyl group goes here. Well, you can do that or you can do that. I don't really care. They like to draw the bond to the carbon, though, just to kind of show you how these hook up for real. And then they just kind of tag these hydrogens out here on the very end. That's why they do that. But for me, I'm not that particular. Whichever way, I don't care. So there is your structure for R2-butanol. Because this is rank 1 up here at the top. The ethyl group is ranked 2, and my methyl group is ranked 3. And folks, that gives me a clockwise rotation. The hydrogen is on the back side. That's where it needs to be. Everything goes according to plan, and everything is normal. So 1, 2, 3 clockwise gives me R. All right, was that bad? Did you feel good about that problem? If so, you're learning. That's why you're here. Okay, so let's look at the other example. They tell me 2s, 3r, oh gosh, 2 chirals? I gotta figure out what to do here? Yeah, I know. It sounds kind of tricky in the beginning. But we'll get through it, I promise. 3-chloro, 2-pentanol. So before you do anything perspective-wise, we're going to write down the structure of the compound. Guys, this goes all the way back to alkane nomenclature. Like many modules back. It's coming back. Again, organic is foundational. You have to build on it. That's what we're doing here. So pent, at this point in the semester, I hope you know what pent means. Pent is 5 carbon. 1, 2, 3, 4, and 5. On the second carbon, that's where my all group is at. Well, the all group is an alcohol group, right? So that's an OH. That goes here. On the third carbon, I have a chloro group. Well, just so I don't get kind of crammed up, I'm just going to point this one up. Again, I don't care. You want to write it down? Write it down. Whatever. Some people are particular. I'm not with that. I pity if you ever get an instructor that is. Okay, so there's the basic structure. Now I'm going to have to go and I'm going to have to figure out how I'm going to show the stereochemistry. How am I going to show this 2s and 3r? Well, I'm going to go through and just add the hydrogens onto these things, right? So this carbon has 3 bonds, so therefore a fourth one is a hydrogen. I'll go ahead and draw it that way. This carbon here, 3 bonds, so there is an understood hydrogen right there. This carbon has 2, this carbon has 3. So chiral carbon-wise, it is true, they're not lying to me. That is not a chiral carbon at number 1. At number 4 and number 5, those are not chiral carbons either, because they have 2 hydrogens and 3 hydrogens. The second carbon, it is chiral. OH, H, methyl, and then all this crap. And then the third carbon, that one's chiral as well. Hydrogen, chlorine, all this crap, and the ethyl group. So I really do have 2 chiral carbons here. Phew, thank goodness, because that's what they represent in the name, so it matches. So now I'm going to have to come up with a structure where I'm going to have to show these 2 chiral carbons all at once, and the answer is yeah, that's what you're going to have to do. So here's how we do it. Start with the first one. You got to start somewhere, right? So we're going to start with this one. That carbon. That's going to be right here. Do it just like always. 1 pointed up, 1 pointed over, 1 pointed, well, it's going to be easier because we've got 2 of them here. It's going to be easier to flip this around a little bit. So I'll do the straight line there, and then my solid wedge, and my dashed wedge. Right? I can do that. That's not a problem. We've just been so used to drawing that straight line left-handed. We just haven't drawn it right-handed, but we can. It doesn't change the rules any at all. That's the way it can be too. It's also going to make it very convenient. Why? Because this next carbon in line, this green one, is a chiral carbon. That's going to go here. So that kind of centers my molecule up a little bit. If not, then this thing would get a little weirder. So I'm only going to focus on this first carbon, okay? Actually, the second carbon in the chain. So what do we put on it? Well, I look at my groups, which is my low priority. Well, you're going to tell me hydrogen. I know you are. Hydrogen is on there. Hydrogen's low priority. It has the lowest atomic number, so hydrogen's going to go here. So now we need to kind of come up with a way that we can ensure that we get a 2s. Which means it's counterclockwise. What's my high priority group here? My high priority group, well, that oxygen and carbon and carbon. So let's just kind of do this normal and see what we end up with. And if not, I'll show you how to fix it. Normally, we would look at this and say, oh, OH, that has the highest atomic number. That's going to go here. Good. That's where we normally put it. And then out of these two, we have this CH3 group, and then we have this carbon with all the crap. So carbon with all the crap would actually come in second. So this is spot 1. This would be spot 2 then, if that was the case. And then spot 3 would be the methyl group that's down here at the very bottom. Okay, well, if this is the ranking, this would go from spot 1, spot 2, to spot 3. Okay, so I'm getting closer, but the problem now is that this goes clockwise. It doesn't go counterclockwise, does it? Because that needs to be the S rotation. And right now we have represented the R rotation. That is not going to work. It's not going to work. I need it flipped. How do we flip it? Well, if you're clever, think about the past problems that we've did. If hydrogen is on the opposite facing bond, then we have to pick the opposite rotation. Oh, that's where this comes in. So here I've set my problem up the right way, like we've always done. It just so happened it didn't meet the S rotation. Is there an easy way to fix it? Oh, yes, there is. Let me show you what to do. You take this hydrogen and you erase it, and you take the methyl group and you erase it, and you switch those. You put hydrogen pointed towards you now, and you put the methyl group pointed away from you. How does that fix anything? Well, look at it. OH is spot 1. This carbon with all the crap is spot 2. And then methyl group is spot 3. This gives me a clockwise rotation. We would normally assign this as R. But because hydrogen is on the opposite bond, because hydrogen's pointed toward me, not away from me, then that means that this is the opposite of what I would normally pick. And I normally would pick R, but now, folks, this is the proper S rotation because that hydrogen simply is on the bond that it should not be on in order to give me the R and the S rotation like we've always talked about. Okay, so I fixed that side. Now let's take a look at the other side. With the other side, some people, because this bond points straight up, some people would take this over here to the right-hand side and point this bond straight down. Okay, if you want to do that, that's fine. I just think it confuses people a little bit when they learn how to draw these things in the beginning. So I'm still going to do this straight line that points up, just like we did on this carbon. All right, and here we have two bonds, one that points straight up, one that points straight to the left. That's kind of our template that we've always used, right? And then over on this side, that will be my solid wedge. And then this is also going to be my dashed wedge as well. So now I've set the template up for that second chiral carbon. Now let's talk about what's there. I have a hydrogen, I have a chlorine, I have an ethyl group, and a carbon with crap. Okay, normally what we would do, we would take the hydrogen, and we notice that's the lowest, so this needs to go on the back end preferably. I look at the highest group out of the three that's left. My higher ranking group, carbon, carbon, chlorine. It's chlorine. It has a higher atomic number, so that would go there. Well, carbon, with all the crap, it's already represented in the structure, right? It points over to the left already. It points over to the left. So what I have left over now is my fourth group, and that fourth group is that ethyl group. So that's going to go here, CH2, CH3. Now, let's just see. Let's just see what we've drawn, and then we double check it just to make sure it is what the problem wants me to put down. So if I rank the groups, chlorine is going to be rank 1. Carbon and carbon is a tie. We move on. Folks, carbon and carbon is another tie. We move on. There's other stuff over here like an oxygen, OH group, right? And then this one runs out. So this is going to be rank number 2. and this is going to be rank number 3. Typically, the more complicated the group is, it's a better chance that it is going to be higher ranked than something else. So if I look at the designation that we've just done, carbon, or group 1, group 2, group 3, there is the rotation that we've represented. That is counterclockwise. That counterclockwise rotation represents at this point S. Is that what we need? Well, we go up here to the top and we see, oh no, it needs an R group. Oh no, I just messed it up. All of that work, and this is not going to work out the right way. Don't freak out. It's a very easy fix, just like we saw with the other carbon. This is how I've ended up with the structure. In order to get this the R, right now this is the S version. It's counterclockwise. What do you think we need to do? I hope that you tell me we will take that hydrogen and we will take this ethyl group and we will flip them. I'll put hydrogen forward and I'll put the ethyl group behind me. It's still rank 1, rank 2, rank 3. I still get this counterclockwise rotation. I would still represent that with an S, but hydrogen is on the opposite side facing bond, which means I need to pick the opposite of the real answer. And that means that this will be an R. So just by flipping that position of the hydrogen and that other group, folks, I've fixed the problem. You don't have to redraw everything. You don't have to do squat other than just simply switching two groups. And in doing that, this is now the R rotation. So let me put R on this side. And there's the structure. That's how we solve these types of problems. Again, it's all three-dimensional. If you have a model kit, it might be great for you to whip out a model kit, start putting these molecules together, and just start looking at them in a 3D orientation. So that way you can start assigning something like this on a sheet of paper to something that's a little bit more real that you're holding in your hands. So you're going to get quite a few problems like this in Blackboard and on the upcoming test. You know, they're going to tell you, here's a name, draw the structure, and then just represent the R group or represent the S group or maybe represent both of them. And we've done these types of examples a number of different times in previous videos. And here was just another example of that. All right. The difference, this juggled two of them together, not just one. Okay, so that's where this video is going to stop. In the next video, folks, I have another vocabulary term for you. And this is called meso. Meso. Okay, so what does meso mean in organic? That's what you'll find out in the upcoming video. We'll start kind of talking about meso groups and meso types of structures, and really how they apply in the stereochemistry world. So stay tuned. We have another term that we need to learn. We need to expand our knowledge in stereochemistry, which is why we have a whole lecture module on it. So come back to me, take a break, take a potty break, right? Go get you some water, do some stretches, get that mind going, get the juices flowing, and then come back and we'll have another chat.